Linear Diophantine equations. Equations of the form GCD of two numbers A and B are two positive integers. GCD of A comma B is equal to AX plus BY. Then X and Y are two integers. And this X and Y are called Bezout coefficients or Bezout identities. Let us consider GCD of 60 and 40 is equal to 8. We can represent this GCD 8 as a linear combination. 8 equal to 60x plus 40y. We want to find out what is x and what is y. Solve a Diophantine equation means finding x and y. The GCD of 97 and 13 and this 97 0 0 and 13, and this stage we can represent as 13 is equal to 97 into 0 plus 13, and then in the next stage we will take 97 here, and we will be getting some 7, so 91, then 6. So this stage we can represent this 97 as the remainder of the previous stage, that is 13 into 7 plus 6. Next stage we will take 13 here, we are getting 2, 12, 1. We will represent this stage as this 13 equal to 6 into 2 plus 1, and in the next stage 6 here we will be getting 6 0. So this 1 is the GCD. Okay, we will write 1 this 6 equal to 1 into 6 plus 0. Okay, then we will try to do the backward replacement from this stage. So here 1 is the GCD. We can write 1 equal to 13 minus 6 into 2. From here we can write 1 equal to 13 minus 6 into 2, and in the previous stage we can write 6 equal to 97 minus 13 into 7. Okay, so it will be 13 minus 6 will be replaced. 6 will be replaced by 97 minus 13 into 7. This is 6, and here we have a 2. This is equal to 13 minus uh, 2 into 97, 2 into 97 plus 13 into 14. That is, we can write it as, here we have 13 and plus we have plus 14, 13. So total 15, 13 into 15 plus minus 97 into 2. So this can be written as 13 into 15 plus minus 2 into 97. So this is in the form ax plus by, or x equal to or a equal to 97. A is 97, x plus by. So this GCD is represented by ax plus by, or a is 97. So x will be minus 2 and y will be 15. We know 97 into 2 into minus 2 is equal to minus 194. 13 into 15 is equal to 195. So 97 into minus 2 plus 13 into 15 is equal to 1. That is the GCD of 97 and 13. Then in general, ax plus by is equal to c as a solution, as solutions if and only if and only if GCD of A comma B, GCD of A and B divides C. If this GCD A and B does not divide C, then no solutions. We can, if this condition is satisfied, we can expect infinitely many solutions for x plus by is equal to c. Remember, A divides B means B equal to A multiple of A. Solve 11x plus 13y is equal to 369. First we have to check if there solutions. GCD of A is 11 and B is 13 is equal to 1. 1 divides 369. This is true. So there exist solutions. Next, let us use the extended GCD algorithm. Use the extended Euclid algorithm to find the Bezout coefficients. GCD of 11 and 30 is equal to A is 11 or A is equal to 11, B is equal to 13. Okay, so 13 divided by 11, 1, 11, then 2, 11, 5, 10, 1. Okay, so we have 13 equal to 11 into 1 plus 2, and this 11 equal to 2 into 5 plus 1. Okay, to the backward replacement we will be getting the GCD 1, it is equal to 11 minus 2 into 5, then we will replace 2 by 13 minus 11 into 1. Okay, so this is equal to 11 minus 2 will be replaced by 13 minus 11 into 1, 11, here we have 5. Okay, and this is equal to 11 minus 13 plus 13 into 5 plus 11 into 5. We have this can be written as we have 11 here and 5 11s here. Okay, so total 11 into 12, sorry, 11 into 6, 11 into 6 plus minus 5 into 13. So we have x equal to 6, we have x equal to 6 and y equal to minus 5. X equal to 6 and y equal to minus 5. GCD of 11 and 13 is equal to 1 equal to 11 into 6 11 into 6 plus 13 into minus 5. Okay, our question is solve 11x plus 13y is equal to 369. Okay, that was the 369. That was the question. We got 1 equal to 11 into 6, that is 11x plus 13 y is minus 5. Okay, so here the right hand side is 369. So we have 1 equal to 11 into 6 plus 13 into minus 5. Our question is the right hand side of our question is 369. So 369 multiply both sides by 369 is equal to 11 into 369 into 11 into 6 plus 13 into minus 5 into 369. We will get 369 equal to 11 into 2214, 11 into 2224 plus 13 into minus 1845. So for this x equal to 2244 and y equal to minus 1845. This is one possible solution. We have said that 11x plus 13y is equal to 369 may have infinitely many solutions. One particular solution is x equal to 2214 and y equal to minus 1845. This is one particular solution. Then in general our equation is ax plus by is equal to c. We know this has a solution if the GCD of a and b, the GCD of a and b is equal to d. This d divides c, then only this equation has we can expect infinitely many solutions. Okay, and this is one particular solution. Okay, we got one particular solution, that is x equal to 2214 and y equal to minus 1845. Okay. Then in the case of x plus by plus c, we can say the general solution x. Okay, this in the particular solution we can say x0 is equal to 2214 and y0, this is a particular solution, so we can say y0 equal to minus 1845. Okay, in general we can say x equal to the particular solution x0 plus b by d, d is the GCD of a and b into t, t is an integer, and y, the general solution y equal to the particular solution y0 minus a by d into t. Remember, this t belongs to set of integers. Okay, this is the case. And we need some positive values of x and y. Then we will proceed like this. We have to find some value for t, which will give some positive values for x and y. Okay. Our issue is need positive values for x and y. Okay, that is, it should be greater than 0 always. That is, let us let us come to our case. Our x0 is 2214 plus b is equal to, this is our a, this is our b, so b is 13, or d GCD is 1 into t, 13t. This should be greater than 0. For this, t should be greater than minus 2214 divided by 13, and is equal to minus 170.31. Then coming to y, our y0 is minus 1845 minus a is 11, d is 1 into t, and this would be greater than 0. For this, t should be less than 1845 divided by 11, and this is equal to minus 167.73. So our t should be less than 167.73, and t should be greater than minus 170.31. So t will have some possible values t. For every t we will be getting some x and So within this range it is minus, okay, minus 167.73. Okay, let us consider a value minus 169. This t value is greater than minus greater than 170.31 and is less than 167.73. so you will be getting x equal to 17 and 14. Okay, if you take t equal to 168, you will be getting x equal to 20 and y equal to 3. If you draw the number line, you are getting 0 here, then somewhere here you are getting minus 167 and somewhere here you are getting, okay, let's consider the numbers, 168 minus 169 and minus 170. So these are the possible values and it is 170. Okay, and here you have 171. So this also less than this but greater than 170. Okay, so you will be considering only these values for, you can consider 167. Okay, you can consider 168. Don't consider this. So you will be considering up to this, only this much values for 3. So when t is equal to minus 170, you are getting positive values for x and y. It is 170, you are getting x equal to 4 and y equal to 25. When t equal to minus 169, you are getting x equal to 17 and y equal to 14. When it is minus 168, you are getting x equal to 20 and 3. Okay, next question is why should we need this why we need positive values for x and y. The question is, why do we need positive values for x and y? For this, let us consider a question. A person X, he want to buy big shirts and small shirts. Okay. Then cost of small shirt, it is rupees 11, and for big one or large size is cost is rupees 18. The total amount he can spend is rupees 1188. Okay, then how many small size shirts and how many large size shirts? Suppose he is buying X number of large shirts and Y number of small shirts, then the total amount will be 18x plus 11y is equal to 1188. Okay, if you take the GCD of 18 and 11, we will get 1, d equal to 1. Then let us see the steps of finding this GCD using Euclid's division lemma. Then take the backward replacement. We will get x equal to minus 3 and y equal to 5. 18 into minus 3 plus 11 into 5 is equal to 1. That is the GCD of 18 and 11. What are our actual, the right hand side of our actual equation is 18 into minus 3 plus 11 into 5 is equal to 1188. So we have to multiply LHS and RHS with 1188. Then we will get 18 into minus 3 into 1188 plus 11 into 5 into 1188 is equal to 1188. Okay, this will be our actual equation. So we will be getting 18 into minus 3564 plus 11 into 55940 is equal to 1188. And we can say our x equal to minus 3564 and y equal to 5940, that is 5940. This is a particular solution. We can say x0 is equal to minus 3564 and y0 is equal to 5940. Okay, then in general x equal to x0 plus b by d into t and y equal to y0 minus a by d into t. And we know d equal to 1. Then our x equal to, we know our x0 is minus 3564 plus our b is 11 and d is 1, so 11t, and our y equal to 5940, that is y0 minus a is 18t, so this will be minus 18t. Both these values should be greater than or equal to 0. X, we know x is the number of shuts and y also the number of shuts, so they should be greater than or equal to 0. For the equation 1, for x greater than or equal to 0, this t should be greater than or equal to 3564 divided by 11, which is equal to 324. For y greater than or equal to 0, this t should be less than or equal to 5940 divided by 18 equal to 330. And if you draw the number line, it will be something like this, 0 and 324 and 330. This will be the range of t. Let us construct a table for each value of t, what we are getting as x and as y. Okay, first let us consider 3 to 4. Our equation is x equal to x0, that is minus three 564 plus 11t and y equal to 5940 minus 18t. This is our equation for x and y. When t is equal to 324, x will be 0 and y will be 108. When x is 325, x will be 11 and y will be 90. When x equal to 326, t will be 326, x equal to 22 and y is equal to 72. And this is y is 36. We know x is the large strut and y is the small strut. Then t is equal to 329, x is 55, that is 55 number of large strut and 80 number of small struts. Then the last value 330, x will be 66 and y will be 0. All this combination gives is equal to the total amount. Is it equal to 1188? Well, let us compute 18 into 0 plus the first one, 18 into when t is 324, we are writing x equal to 0 and y equal to 108. 11 into 108, this equal to 1188. Okay, so all this gives 1188. So all these solutions are valid. So he can buy 0 number of large sets and 108 number of small sets. He can meet his total, that is 1188. If we buy 11 large shots and 90 small shots, he can meet his requirement. The total amount will be 1188. Okay, so we can use this table to tell minimum of x plus y, it is 66. That is, he is not buying the small shots, he is buying only 66 large size shots. He can meet his requirement. The total amount will be 1188. So this is the smallest total number of shots. Okay, smallest quantity, minimum quantity of items. This is 66. The maximum quantity of items he can buy is 108. That is 0 large shots and 108 small size shots.